Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 3 of a unit electrostatic potential and capacitance. So let's begin with the today's class. Today I am going to discuss about the relations between electrostatic potential and electric field. So let's begin. When in previous classes when we discuss about that what is potential and what is potential difference, we came to know that potential difference dv should be is equals to work done divided by charge. This stands for work done, and this is charge q. So potential difference, it is in work done divided by charge, and as I know that what is work done it is a dot product, it's a scalar product of force into displacement. In this situation, I am doing the work done against the force. That means it is a negative work done, and that's why it is f dx cos 180 degree. As cos 180 is minus 1, so this comes to an minus of f dx. So let's replace the value of work done in this relation. So it should look like dv is equals to minus of f dx divided by q, and I know that f is equals to q into e. So let's replace this value of q into in this relation, and let's look. So if I replace this, then I could have a dv is equals to minus of q into e dx divided by q. This q and this q has been cancelled out, and what I'm having is it is a dv is equals to minus of e dx. So this is e is equals to minus of dv by dx. This is electric field, and this is potential difference. Yes, dx, change in position, or you can even write as it's a change in distance. So what I can derive is that electric field intensity at a point is equal to the negative gradient. Do you know this word? Gradient. Yes, whatever the term that has been divided by distance, that termed as in gradient. That electric field intensity at a point is equal to the negative gradient of the electric potential at that point. So this is the relation which relate electric field and potential with each other. So please do remember this. So let's look what all we can derive from this. First, on a very basic note, I can have the relation is E is equals to minus of dV by dx. So if I have been given a voltage and I need to find out the electric field, I can just differentiate it with respect to x, and electric field will be available. From this, from this, I can always write dv is equals to minus of e dx. And if I integrate this too, then please remember this is not v, this is delta v. This is change in potential is equals to minus of integration of E dot dx. So if I require a voltage and electric field has been given, then I need to integrate this. I repeat, then I need to integrate this, and delta V would be available. Are you sure? Yes. Can you do this? Are you sure? Yes. This is first set of summary. A second. If graph has been given, let's say a graph of V versus X is given, and I require an electric field. What should I do? I can write like this. It's a negative of slope. It's a negative of slope of V versus X graph. A first case. And as this is a second case, In this case, in this case, if I have been given a graph of E versus X and I require mode of delta V, then I need to find out area. I need to find out area of E versus X graph. So I hope these things are clear. First, E is equals to minus of dV by dx that we have already derived. And from this, we know that dV is equals to minus of E dx. So if I require delta V, please remember this is delta V. This is not a potential. This is potential difference. Yes, this is not a potential. This is potential difference. So this delta V that should be is equals to minus of E dx. And it's an integration of minus of E dx. If graph given, graph of voltage versus distance, let's say voltage versus distance is given, and you require to find out the electric field, then that graph or the slope of that graph will give me an electric field. Yes, but it would be a negative of slope. And if I have been given a graph for the electric field versus distance, and I need to find out the magnitude of change in potential. What I need to do is I need to just find out the area of the graph and things will be done. So, are you done with this? Yes. Will you able to solve this kind of questions? Will you? Let's look at this. Suppose potential of a region is given as E is equals to 4x square minus of 2x plus 5. What is the unit of electricity? This is V. Potential of a region is given as V is equals to 4x square minus 2x plus 5. You have been asked that find out electric field at x equals to 4 meter. So what you need to do is you need to just differentiate this because V is given, electric field is required. Voltage is given and electric field is required. So what you need to do is E is equals to minus of dV by dx. This should be minus of d by dx of 4x square minus of 2x plus 5. So that should be minus of 4x square, it's an 8x minus of 2, and differentiation of any constant would be a 0. So I put it as 0. I require an electric field at x equals to 4. So let's replace x with the 4. So 8 into 4 minus of 2. So this is 32 minus 2. This is 30, but minus of 30. What is the unit of electric field? What is the unit of electric field? Yes, one of the units. It's a Newton per coulomb. Or yes, you can derive it from here as well. It's a volt per meter. Or 30 volt per meter. So can you do this kind of thing? Are you sure? Can it be done? Can it be done by you guys? Are you sure? Yes. Let's look at the next question. And very important. Suppose you have been given that potential in a region is given as V is equals to xy plus yz plus zx. find out electric field at 2, comma 2, comma 2. This is what they have given. Now, go through this once, and I will let you know what is the difference. That here they have given it's a potential, and that is given as xy plus yz plus zx. That means they have given a potential of certain specific region in a 3D. It's a three-dimensional. When you were doing the previous question, it was just, if you revise it, it is just a relation of single dimension. It's a relation of single dimensions. But here it is of three dimension. It's an x, y, and z. You know that x, y, and z are perpendicular to each other, and this is the question. Now, let me know that I need to find out the electric field. It is scalar or vector? Electric field is scalar or vector? Yes, it is a vector. And when it is a vector, I require a direction of, or I require a magnitude of electric field in x, magnitude of electric field in y, magnitude of electric field in z direction, and then I need to add them using law of vector algebra. Yes, do you understand what I mean? You need to find out the electric field in x direction, electric field in y direction, and electric field in z direction. And then you need to just add them, but according to the vectors rules. Yes. So let's begin. But but how could I find out the ex? How could I find out the ex? For this, we are going to take a help from this kind of differentiation. Maybe you know this, but for medical students, maybe this is a new to them. This is partial differentiation. And what is it? It is not a new thing for you guys. What you need to consider is that when I differentiate with respect to x, when I differentiate with respect to x, y and z behaves like a constant number. So let's do it. You can do it. Minus of del by del x, it is xy plus yz plus zx. Yes, so that should be is equals to, look at this here, del by del x. I am differentiating it with respect to x. So for me at this point of time, y and z behaves as a constant. So let's, this is minus, that is del by del x of xy plus del by del x of yz plus del by del x of z into x. So this is equals to minus of, look at this, del by del x of x, it's a 1. So the remaining term would be y plus del by del x of y into z, as y is constant and z is constant because I am differentiating with respect to x. So this would be a 0 plus del by del x of z into x. Yes, it is z. So now I need to replace, or I need to find out an electric field at location 2, 2, 2. This is value of an x-axis, this is in y, and this is in z, that you know. So if I replace this, it is a y plus 0 plus z. It's a 2 plus 0 plus 2. It's a minus of 4. If I write according to the vector, it is minus of 4 I can. Yes. Can you do this? Are you sure? So let's do this very quickly. So v was xy plus yz plus zx. Now you require ey, which should be minus of del v by del y. So if I keep aside, now what would be the differentiation of first? It's xy. This is with respect to y. So when I differentiating this with respect to y, for me at this point of time. X and Z behaves as a constant term. So this is X plus YZ. The del by del Y of Y is 1. So the remaining term would be a Z plus ZX. Yes, Z is constant, X is constant, and that multiplication will be always a constant. So this would be a 0. So this is equals to minus of 2 plus 2 plus 0. So this represents minus of 4 later if I write EY or vector EY. Now Ez. This is equals to minus of del V by del Z, and that stands to you are going to differentiate this term with respect to Z. So for you X and Y is constant, and differentiation of any constant term would be a 0. So this would be a 0 plus del by del Z of YZ, it's a Y, del by del Z of ZX, yes X. This would be minus of 0 comma 2 plus 2. This should be is equals to minus of 4. This is EZ for me. Now, what I need to find out, I need to find out electric field. It should be, it should be under root of EX square plus EY square plus EZ square. This is E is equals to under root of EX square plus EY square plus EZ square. So that should be so 4 square plus 4 square plus 4 square. What it would be? What it would be? Yes, it is 4 under root of 3 joule per liter. This should be your final answer. This should be your final answer. So, can it be done by you guys? Are you sure? Will it be? You want one more practice question of same concept? Do you? Do you require one more question of same concept? Yes. Will you be able to do it on your own? Yes. So let's have it. Let's say voltage in a region is given as V is equals to x square y plus y square z plus z square x. You've been asked that to find out electric force acting on a charge of 2 coulomb at 1 comma 1 comma 1. You need to find out electric force acting on a charge of 2 coulomb at 1 comma 1 comma 1. This is what they have been asked. Now tell me, how could I do this? First thing, that what is given and what all they require. They have given a potential. They have given a voltage at a specific region, and they want us to calculate electric force. So for electric force, I know that F is equals to Q into E. Now, charge already given by them. It's a 2 coulomb. What only I require is electric field. Now electric field is a vector quantity. I require an electric field in X. I require an electric field in Y. I require an electric field in Z. Yes. So what I need to do is we need to just partially differentiate this and find it out EX, EY, and EZ. So let's do this very quickly. This is V is equals to X square Y plus Y square Z plus Z square X. So Ex should be is equals to minus of del V by del X. This is equals to minus of del by del X of X square Y plus Y square Z plus Z square X. So that should be is equals to minus del by del X of X square. It's a 2xy plus I'm differentiating with respect to x. So this y and z is a constant. Put it as 0 plus del by del z del x of z square x. It is a z square. I require this at 1 comma 1 comma 1. 1 comma 1 comma 1. So let's put up the value equals to minus of 2 into 1 comma 1. It's a 1 plus 0 plus 1. So this is equals to minus of 3. This is ex minus of 3 I can. Now ey. Let's do it. It's a minus of del v by del y. So this should be is equals to minus of del v by del y. It's an x square y, so it would be an x square plus y square z. It's a 2yz plus z square x. It's a 0. So this is equals to minus of 1 plus 2 because y is 1, z is 1. It's a 2. So this is equals to minus of 3. And it is in y cap, it's a j. Next ez, it would be a minus of del v by del z. So what it would be? Minus of, let's check, x square and y. I am differentiating with respect to z, so it would be a 0 plus y square into z, and differentiating with respect to z, so it is y square plus z square x. So this should be 2zx. Let's replace x, y, and z with 1 comma 1 comma 1. So it would be a minus of 0 plus y square, it is 1 plus 2 into z into x, it's a 2. So this is equals to minus of 3 k cap. This is E z. So now what I need to find out, I need to find out the E net, and that would be equals to under root of ex square plus ey square plus ez square. So this is under root of 3 square plus 3 square plus 3 square. This is 3 root 3 Newton per Coulomb. But this is not all. What I need is I require a F net. So F is equals to Q into E. Charge given was the 2 Coulomb multiplied by E. This is 3 root 3. So that would be is equals to 6 multiplied by root 3 Newton. This is the force I'm looking for. Yes. What was your answer? Is it same? Is it? Are you sure? Yes. Let's move on to the next question. Now, I hope these things are clear to you that if voltage is given and you need to require an electric field, then you just differentiate it. If it is in three dimensions or if it is in more than one dimensions, you need to use a partial differentiation. And if it is in a single dimensions, then the things would be okay. Yes. Now, let's do a reverse thing. Let's do a reverse thing. Suppose they have given that electric field in a region is given as E should be is equals to, let's say, 4 I cap plus 2J Newton per Coulomb. Find out potential at 2 meter if potential at origin is 0. What should I do? Go through the question and do a rough work in your mind. What should I do? What is given to me? Yes, it's an electric field that has been provided, And what do you need to find out? You need to find out the potential. So what was the thing? Yes, you might be assuming correctly. It's a delta V that is equals to minus of E dot dr. Yes, it's a E dot delta x or E dot dr. You can write whatever you want. So now every time you need to follow a certain procedure. First, you need to find out the dr. That dr would be always a dx in I cap plus dy in j cap. Here it is up to j only. If it was for k as well, then I will write it as a dz in k cap. Yes, are you done with this? Now, what I need to do is it's a delta V is equals to minus electric field P. This is equals to 4 I cap plus 2 is meter. Having a dot product dx of I cap plus dy of c. So this should be this is I cap multiplied by I cap. This is 4 dx plus plus 2 dy. Now, what is my next? What is my next? We say to find out potential of 2 chemical. This is for x and this is for y that we know. If potential at everything is 0, so we need to integrate this from 0 to 2. And as we perform this, that would be the final answer. Yes, you understand what I mean? So let's do it. So delta V is equals to minus of integration of 4 dx from 0 to 2 plus integration of 2 dy from 0 to 2. So this would be 4 integration of 4 dx. It's a 4x and my limits will be a 0 to 2 plus 2 into y. Integration of 2 dy is 2y from 0 to 2. So this is equals to minus of 4 into 2 plus 2 into 2. So this is minus of 8 plus this would be minus of 12 volts. Yes, this is the W. You understand the process? Do you? Will you able to solve this kind of questions? Now, one very good thing about the voltage is it is a scalar. So we are not bothering about what is in X, what is in Y, what is in Z. And we are just integrate this. We are just integrate this. But before we do an integration, you need to assume an dr. You need to assume a dr, and that dr would be always or dxi plus dyj cap kind of thing. And then you need to perform a dot product. You need to perform a dot product with the electric field. Yes, why dot product? Why it is a dot product and not a cross product? Why is it so? Do you have answer of this? Do you? Yes, it is a scalar product because whatever the outcome I am having, it's a delta V, it's a voltage, and voltage is a scalar product. So I need to perform a dot product of these two vectors that can give me a scalar product. Yes, so I need to have a dot product and then I simply need to integrate this. So will you be able to solve this kind of questions? Will you? Are you sure? Are you okay? Let's look at the next question. The data is given that in the figure shown, the electric field intensity at R is equals to 1 meter, R is equals to 6 meter, and R is equals to 9 meter in voltage per meter is yes. So graph is given. It's a graph of V versus R. R is in meter. And what do you need to find out? You need to find out electric field intensity. So as we discussed, it is an E is equals to minus of dV by dr. Yes. So when you need to divide the things, you are going to find, slope of this graph. So let's work it on. Let's work it on. How could I do this? How could I do this? So let's look at r is equals to 1 meter. At r is equals to 1 meter. That r is equals to 1 meter would be somewhere here. So if I find it out a slope electric field at 1, then what I need to do is I need to find out a slope, and for slope I can have three options. First option delta y by delta x. Second option dy by dx. And third option tan theta. This all are the options. I'm sure you have been studied this in class 11. Yeah, this is for just a revision purpose. So to find out the slope, I can have three options. One delta y by delta x. Another dy by dx. And third, it's a tan theta. So let's begin with the delta y by delta x. This is 10. This is 0. So this is 10 minus 0 divide by, this is 10, this is 0, divide by 2 minus of 0. So this is 5, but it is a minus of this slope, so it would be a minus of 5. Yes. Now, now R is equals to 6. That means I require an electric field at 6 meter. Now look at this. From 2, at 2 meter, voltage is 10 volt. For 8 meter, voltage is again 10 volt. Does voltage changes from 2 to 8? Does it? No. If voltage does not change, then what I can have is that electric field is equals to, let's say it is a delta y by delta x, and as delta y does not change, it is 0 by anything. Doesn't make any difference because it converts to a 0 only. Are you sure? Yes. Let's look at next. It's R is equals to 9 meter. 9 meter will be available here somewhere. So this electric field at 9. This is E is equals to delta y by delta x. It's a dv by dx, obviously. Minus of. So this is minus of delta y. This is 0. This is 10. So this is 0 minus of 10. Divided by delta x. This is 10. This is 8. So it's a 2. So this is equals to minus of 10 minus minus plus plus 5 again. So will you able to solve this kind of things? Are you sure? Are you? Yes. So answer would be minus 5 comma 0 comma 5. This would be the correct answer. Yes. So let's do the next question. What is given and what they have been asked? Go through this, but do it quick. What they have given is a charge of 6.25 microcoulomb. So charge is given, it is 6.25 microcoulomb. In an electric field is acted upon by a force. Yes. F is equals to 2.5. What do you need to find out? You need to find out potential gradient. It is a dV by dx is required. So what can I do is, it's an F is equals to Q into E. So if I find out the E, electric field, it's a F by Q, as well as it is of minus of dV by dx, but here they are interested in magnitude only, so I can have a dV by dx. So let's find it out. This is F by Q. F is 2.5. This is 6.25 into, this is micro. This is 10 to the power minus of 6. So this would be a d, this would be of dV by dx. Yes. So this is 2.5. This is 6.25. I know that 25 square, it's a 6.25. This is 2.5. So this would be 10 to the power 6 divided by 2.5 should be is equal to dv by dx. Are you sure? Yes. So if I write this as a 10 into 10 to the power 5 divided by 2.5, d is equals to dv by dx. So this dv by dx, d is equals to 2.5 4 jump. That is 4 into 10 to the power 5 volt per meter. This will be the answer. Yes, easy, very easy. Yes, I hope you can do this. Let's move to the next question. What all they have given and what they require. They said that potential. They said that potential at the origin is zero. Due to electric field, it is 20I plus 30J. And you require a potential at point P. It's 2 comma 2. Yes, it is the same question that we already did it. So, so what all they have given? It's an electric field that has been given. It's a 20I plus 30J. What we require? We require a potential. How can we do this? Yes, del V is equals to minus of E dot dr. Now, what is dr? As I know, dr would be equals to always dxi plus dyj cap. So while finding out the delta V, first I need to dot product of this. It's a delta V should be is equals to minus of delta V is equals to minus of it's a 20I cap plus 30j cap dot dot dxi cap plus dyj cap. So if I perform dot product of this, it should be minus of 20 dx plus 30 dy, and I need to integrate this. I need to integrate this from, as they said, potential at origin is zero. So this is from 0 to 2 minus of 30 dy from 0. Yes, this is delta V. This should be the delta V. So if I do this, it is a delta V should be is equals to minus of 20 dx minus of 30 dy. So this is equals to minus of 20 into x. This is from 0 to 2 minus of 30 into y. Again this is from 0 to 2. So this is equals to minus of 20 into 2 minus of 30 into 2. So this would be minus of 40 minus of 60. This is equals to minus of 100 volt. This is V final minus of V initial. But as they said, it's a 0 when they are at origin. So V final would be equals to minus of 100 volt. I hope these things are clear to you. And from next onwards, you will able to solve this kind of questions. Yes, will you be able to solve this kind of questions? Are you sure? Are you sure? Can it be done? Yes. Let's look to the next question. What they have given. They have given that electrostatic potential V at any point xyz in space is given as V is equals to 4x square. And four options are given. What do you need to find? That first option says the y and z components of electrostatic field at any point are not zero. The x component at any point is given by minus of 8x. The x component at a point of 2 comma 0 comma 2, it's a minus of 8. Okay, and the y and z component of the field are constant in magnitude. That means they have given the potential and they want you to find out the electrostatic field. So do I have any relation which can relate potential and electric field? Do I? Do I have anything? Yes, I can have it. It's an E should be is equals to minus of dV by dx. Or you can rather write it as a delta V by delta x. I take this freedom because it is a 4x square only. It is in x direction only. So So this is minus of d by dx square, sorry, d by dx of 4x square. So that would be is equals to minus of 8 into x. This is equals to minus of 8 into x. So now let's again check the options. They said the y and z components of the electrostatic field at any point are not zero. No, it would be a zero because if I do Ey, it's a del y by it's a del v by del y. Sorry, it's a minus of del by del y of 4 into x square. As I am differentiating with y, this x would be converted to a zero. Suppose the same thing if I perform with z also, it's a del v by del z should be is equals to minus of del by del z of 4 into x square. I am differentiating with respect to z and this is of x, so it would be a 0. So they are 0. So this statement cannot be true. The x component of any point is given as minus of 8x. Yes, that is what we have pointed. This would be correct. The x component at a point 2 comma 0 comma 2 is minus it. Is it? No. If I put a 2 here, it would be a minus of 16. They are talking about minus x. So this would be incorrect. The y and z components of the fields are constant in magnitude. No, they are 0. So this would be the correct answer. Yes. Yes. Can you do this? Are you sure? Are you sure? Okay. Let's check it out. The new questions. Next. Next. Look at this very carefully. What they have given. They have given that potential at a point x due to some charge situated on the x-axis is given as Vx is equals to 20 divided by x square minus 4 volt. The electric field E at x equals to 4 micrometer is given x. So what do you need to find out? You need to find out the electric field first thing. What is given? They have given the x. They have given the voltage in x directions. So what you need to do is you need to simply do the differentiation. E is equals to minus of dv by dx. But but the beauty of this question is that it contains a 20 divided by x square minus 4 and you need to differentiate this with x. So there may be a certain difficulty in differentiating it. Yes. So do one thing. Take a 10 seconds of time and think. Can you do this? Can you do this? Will you be able to solve this? Can you? Is it possible by you guys to do this? Are you sure? Are you sure? Can you do this? Will you? Let me help you guys. That V is given as 20 divided by x square minus of 4. And what I require? I require an electric field at x equals to 4, at x equals to, yes, x equals to 4 micrometer. So this E should be is equals to minus of dv by dx. This is equals to minus of d by dx of, can I write like this? It's a 20 into x square minus 4 to the power minus of 1. Yes, can I? Okay. So that should be is equals to minus of 20 into d by dx of x square minus of 4 to the power minus of 1. And if I differentiate this, this is equals to minus of 20 into minus of 1 into x square minus of 4 to the power minus 2. I am using n into x to the power n minus 1 multiplied by, as I need to apply chain rule, x to x. So this would be the thing. So this is minus of 20 into 2x, then minus minus plus. So this would be a plus divided by x square minus of 4 to the power plus 2. So that should be is equals to 20 into 2 multiplied by micrometer. So this is 4 into 10 to the power minus of 6. Yes, micrometer. Divide by. Divide by. This is x squared. So again, this is 16 into 10 to the power minus of 12 minus of 4 to the power plus. Now, the rest of the things can be done by you guys. Yes, this is Newton per coulomb. So please do differentiation or integration with utmost care, because sometimes in maybe in uh, little hurriness, or maybe we are left with very little amount of time, we make a mistake and we lose the numbers. So please, it's a request, do as many questions as possible, and if you are doing this, then only then your accuracy will improve and your numbers will improve. Otherwise this is not possible. Otherwise this is not possible to do this kind of stuff in a very limited amount of time. So let's find it out. In this session, we have been discussing about the relation between electric field and potential. Even in the next session, we are going to discuss the same, but we are going to discuss the potential of let's say sphere, a hollow sphere, a conducting sphere, and that kind of stuff. So till then, bye bye. But before you leave, please remember, we need to practice hard, and only practice can save us. Thank you. Bye bye. Take care.